Okay, this video is going to remind us what long and synthetic division are helpful for with polynomials. Polynomial long division and synthetic division can be really helpful when we're looking at polynomials and trying to factor, or more importantly, if we're trying to find the zeros of a polynomial, which remember the zeros of a function, basically the solutions when y equals 0 or solutions when the equation is equal to 0. They're the x-intercepts. They can be very helpful when you're trying to solve any kind of a polynomial equation. Now, again, this video is essentially for pre-calc students, so we're just kind of reviewing synthetic and long division. And in this video, we're going to concentrate pretty much on synthetic division. So let's go ahead and move forward here. Synthetic division works only when you're dividing by linear divisors. So the problem over here at the left is sort of an ideal synthetic division problem. X cubed minus 19x minus 30, again, is our dividend. That's what we're going to divide into. And x plus 3 is our divisor. Now, you'll remember with synthetic division, we always want to divide by the zeros of the divisor. So we want to take x plus 3, set it equal to 0, and we figure out that x would equal negative 3. So when we go to set up our synthetic division, and you can set this up in a couple of different ways. Some books just make one large bar. I tend to do two. Then negative 3 is going to be what goes in the box. It's what we're dividing by. Again, that's coming from the divisor. And all of the coefficients of the dividend are going to go next to that. So we're going to say, well, there's 1x cubed. So I'm going to say 1 here, because remember that was the x cubed term. And then I'm going to work my way down. Now you'll notice there is no x squared in the numerator. So therefore there is 0 x squareds. There were negative 19 x's, right, or a negative 19's coefficient of x, and negative 30 in the end there. Now, I don't need to write that little x in there, so I'm going to take that out. Again, if you want to label them kind of like you did with the x cubed, if you want to label them above, you can do that. But in the end, it's x cubed. We should have 4 terms, right? Third, second, first power, and constant. Next step, I'm going to drop that first coefficient down. So we're just going to lower that 1 down below. And now I'm going to start the process. Let's take our number that was up in the box, right, our divisor. We're going to multiply that by the number down here below the bar. So negative 3 times 1, and I'm going to write it back up here, is negative 3. Then we're going to add 0 plus negative 3 is negative 3. Back to the multiplying again. So again, negative 3 times negative 3 would be 9. Negative 19 plus 9 would be our negative 10. I'm going to multiply again. Negative 3 times negative 10 is 30. And notice negative 30 plus 30 is 0. So it just came out cleanly. Remember, this would have been our remainder, but we don't have a remainder. It went in there nice and clean, which just tells us that, again, the answer to our synthetic division problem comes from our numbers 1, negative 3, and negative 10. Well, remember, if we started with an x cubed, we now have 1x squared, right? This is going to be x, this would be your constant, and again, this would have been your remainder. So we're going to say we have 1x squared minus 3x's minus 10, and because there's no remainder, we don't have to write one in there. Now, over here at the right, it's a little trickier when we've got x squared plus x minus 1. Again, that's not a linear divisor, right? That's not similar to x plus 1 up here. It's an x squared. Now, we could synthetically divide a couple of times over, but that will make for a little bit of a mess unless we have, again, like we did over here at the left, that 0 remainder, right? But we can still do it if we can factor the bottom here. So let's take a look. What would multiply to 1 and add to negative 1? Well, again, right off the bat, I'm going to go ahead and say there's nothing. So actually, we really are kind of not going to be able to divide that one because, again, we just can't do that. Can't synthetically divide unless it's a linear factor. Now, you'll remember, just for an example, if there were a divisor, if there were a remainder, we would have added that on to the end of our polynomial, and we would have taken whatever that r value was, so 0 right now, and still we're dividing by x plus 3. Now, I don't have an example for you of one of those on our division here, but hopefully in the next couple of videos, you'll probably end up with something like that. So make sure you keep watching and have a great day.